In this video, we will see some more matrix manipulations. Earlier in two videos, we have seen some matrix manipulations and some utility matrices. Now here we'll see some operations which you can perform on the matrices. So here these are the operations which can be performed on the matrices. First is the ROT 90 degrees. 90, that is it will rotate a matrix by 90 degrees in the counterclockwise direction. Then you have flip LR. It will flip the matrix from left to right. Next is flip UD, which will flip the matrix from up to down. Then you have TRIL, which will extract the lower triangular part of the matrix. Next is TRIU, which will extract the upper triangular part of the matrix, and then you have reshape, which will change the shape of the matrix. And I have listed some special matrices which will create some special matrix types. Here the execution for this is not shown, just it is for the information. Now here you can see for flipping you have two commands, flip LR and flip UD. For triangular extraction we have TRIL and TRU. Then for reshaping I have one command, reshape. For rotation we have ROT 90 degrees or 90, and here these are some of the special matrices. You can have a glance on this, but there is no execution shown for these. The first operation is ROT 90, which will rotate a matrix in the counterclockwise direction by 90 degrees. So here if you have A is equal to 1, 2, 3, 4, which will create a matrix of 2 rows and 2 columns, and we perform the rotation operation on this matrix. I will take a variable B is equal to ROT 90 of A. When I perform this, I will get B is equal to 2, 4, 1, 3. So here the elements of this A matrix, these are rotated in counterclockwise direction. You can see 2 has come here, okay, 1 has come here below, then 3 has come on in the place of 4, then 4 has gone in the place of 2. So it is rotating in the counterclockwise direction by 90 degrees. Next is flip LR, which will flip a matrix from left to right. So here if you have a matrix A is equal to 1, 2, 3, 4, 5, 6, which can be displayed like this, which has 2 rows and 3 columns. Now we'll perform the flip LR operation on this. So here when you do this, you will get B is equal to 3, 6, 2, 5, 1, 4. It is flipping the matrix from the left to right. So here 3, 6, which was in the right, it has come to the left, and 1, 4, which was there in the left, has come to the right. And 2, 5, it is in the same place. If you want to know more about this, you can change the size of the matrix while execution and see. Next is flip UD, which will flip a matrix from up to down. So if you have A is equal to 1, 2, 3, 4, 5, 6, that is 2 rows and 3 columns like this, and you perform flip UD operation on the matrix A, then you will be getting B is equal to 4, 5, 6, 1, 2, 3. That is the first row has come to the second row and the second row has come to the first row. So the elements are being shifted from down to up. Next is TRIL, which will extract the lower triangular part of the matrix. Suppose I have a 3 cross 3 matrix for which I'll write the command as A is equal to 1, 2, 3, then semicolon 4, 5, 6. This should be semicolon, it should not be colon, 7, 8, 9. So here you get A is equal to a matrix of 3 cross 3 order. Now here I will perform B is equal to TRIL A. That is I am performing the TRIL operation on matrix A. It means that it has to extract the lower triangular part of the matrix. Lower triangular part of the matrix is 4, 8, 7. So it will not just extract this part, but here this 1, 5, 9, which is the main diagonal element, these will also be displayed along with 4, 7, 8, but the upper triangular part, that is 2, 3, 6, these will be made as 0. Okay, so when you perform this TRIL on A, you will get B is equal to 1, 5, 9, these main diagonal elements are as it is, whereas 2, 3, 6, this has become 0, and 4, 7, 8 we are getting in the lower triangular part. So it will display the lower triangular part of the matrix along with the main diagonal elements. Next is TRIU extracts the upper triangular part of the matrix. Now again I'll take the same matrix here. So again I have made a mistake here. It should be a semicolon. It should not be a colon. Now A is equal to, you will get 1, 2, 3, 4, 5, 6, 7, 8, 9. This matrix will be displayed. Now we'll perform TRIU operation on this matrix. So B is equal to TRIU of A. Now what it has to do? It should display the upper triangular part of the matrix along with the main diagonal elements, and this 4, 7, 8 must become 0. So you can see you will get this. So you are getting 1, 5, 9, the main diagonal elements along with the upper triangular part, and the lower triangular part has become 0. Okay. Next is reshape. Reshape, it will change the shape of the matrix. Suppose we have a row vector, that is A is equal to 1, 2, 3, 4, 5, 6. Now I want to reshape this matrix into 2 rows and 3 columns. So I can write it as B is equal to reshape which matrix? A matrix I want to reshape 2, 3. Okay, A, 2, 3. Here it will reshape this matrix into 2 rows and 3 columns. So you will get B is equal to 2 rows like this and 3 columns. Next you have, suppose I want to change. Now B is equal to reshape A, 3, 2. Now I want 2 rows and 2 columns. 3 rows, 2 columns. So I will get this output. B is equal to 1, 4, 2, 5, 3, 6 like this. So here this is about reshaping the matrix. Now we'll see the execution. We will take a matrix A is equal to, I'll take a 2 cross 2 matrix, 1 space 2 semicolon 3 space 4 and close the square bracket. So here we have taken a square matrix of the order 2 cross 2. Now we want to rotate it by 90 degrees. So I'll take another variable B, which will be my new matrix after the rotation by 90 degrees. That is equal to, the command for rotation is ROT 90. Rotation by 90 degrees. So it will rotate the matrix A counterclockwise. Okay, counterclockwise by 90 degrees. It will not flip it. It will not rotate it in the clockwise direction. It will rotate it in the anti-clockwise direction. That is the counterclockwise direction. So here I want to rotate my matrix A. It should be a round bracket. Okay, round bracket of capital A. You should be very careful with the with the uppercase and the lowercase. Okay, now run. So here you can see this matrix, it has been rotated in counterclockwise direction by 90 degrees. Earlier 4 was here, 2 was here in the second row, first row, second column. Now it has come in the first row, first column. Okay, similarly 3 has come here. Then 1 from first element to, that it was in the first row, first column. Now it has come in the second row, first column. So here it has rotated in counterclockwise direction. You can see my cursor here. I am rotating in the counterclockwise direction. Okay. So here this will be the clockwise. This will be the counterclockwise. So this is counterclockwise direction. Now A has been rotated to A has been rotated by 90 degrees in counterclockwise direction. Now next, suppose I have a matrix. I'll define a matrix 1, 2. I can take this matrix also. 1, 2, 3 semicolon 4 space 5 space 6. Okay. Now I'll display it. So when I display it, I'm getting it as 2 rows and 3 columns in this matrix. I want to flip it from left to right. So when I want to flip this matrix from left to right, I can write it as B is equal to FLIP LR. Okay, B is equal to FLIP LR. That is flip from left to right of capital A. Now we'll see what we'll get. So here it is rotating from left to right. Okay, it will be very, very clear to you when I take a matrix of order 2 cross 2. I'll take it as 2 cross 2. 3 space 4. Now run. So here earlier it was 1, 2, 3, 4. Now it has been flipped from left to right. That is, the left column elements have come to the right, and the right column elements have come to the left. That is, 1 3 have come this side and 2 4 have come this side. So it is rotating from left to right. Next is flipping a matrix from up to down. Okay, now here I'll take 1 2 3 semicolon 4 5 6, and here for flipping the matrix from up to down, I'll write it as UD, FLIP UD, round bracket, in that you have capital A. Now we'll run and see it. So here you can see the matrix, the matrix was 1 2 3 4 5 6. The first row has come down now. That is, we have flipped the matrix from up to down. First row was 1 2 3, now it has become the second row, and second row was 4 5 6, now it has become the first row. This is about flipping the matrix. Next is extracting the lower triangular matrix. For that, I will take a 3 cross 3 matrix here. I'll clear this first, command window. Okay. Now I'll take a matrix A. You can take any variable. I'm taking it as A. Opening square bracket, 1 space 2 space 3, then 3 space 4 space 5, semicolon 5 space 6 space 7. I'll take it as 7 space 8 space 9. Okay. Now I'll run it. So this is my 3 cross 3 matrix. I want to extract the lower triangular matrix. Okay. So when I want to extract the lower triangular matrix, you will get the main diagonal elements also along with the lower triangular elements. Lower triangular elements of this matrix are 3, 7, 8. I should get this part, and remaining part, this 2, 3, 5, it must become 0. Okay. So now to extract the lower triangular part of the matrix, we will be having B is equal to TRIL. Okay. L is for lower triangular part of the matrix. Opening round bracket, capital A, closing round bracket. Now run it and see. So here you can see the upper triangular elements have become 0, as we are interested only in extracting the lower triangular elements. So the main diagonal elements are being displayed along with the lower triangular part of the matrix. Now similarly, now this is my A matrix. Okay. Now I want to extract only the upper part, that is the upper triangular part of this matrix, that is 2 3 5. This 3 7 8 must become 0. So I have to type it as B is equal to TRIU. Okay, TRIU. Now play it, run it. You will get, I have put a semicolon, no? So the output is been suppressed. I'll remove the semicolon. Now I'll run it. So what I'm getting, the lower triangular part has become 0 because I am interested in only the upper triangular part. So 2 3 5 along with the main diagonal elements. Okay. Now one more operation on the matrix is reshaping the matrix. Okay. So here, suppose I have A is equal to a row vector 1 2 3 4 5 6. Now I want to reshape this matrix. That is, I want to write this matrix in the form of rows and columns. So what I have to do is capital B is equal to RESHAPE, reshape. Okay, reshape which matrix? Capital A matrix into how many rows? Into 2 rows and 3 columns. Okay. Now and here it should be a round bracket. We'll run it. Okay, what we are getting here? I have put here a full point. There should be a comma. Now run it. RESHAP, reshape A, 2, 3. Wait, it should be comma. I have put here full point. A, 2, 3. Okay, so here you can see we were having a row vector which has been converted, that is reshaped into a matrix which is having how many rows? 2 rows and 3 columns. Suppose I want 3 columns and 2 rows. I can change this here. Change it. Now run it. So here you can see that now we have got a matrix which has 3 rows and 2 columns. Okay, so this is how you perform the various operations on matrix, that is matrices. I hope you have understood these various operations which we can perform on the matrices. Thank you.